Hello everyone and welcome back to another project. In this project I'm going to show you on how you can control the speed of a DC motor using the hand gesture based on artificial intelligence, more specifically using computer vision without using any kind of sensors. So in the previous videos I've already shown you on how you can control the speed of a DC motor by using the PWM signal with a variation of temperature. You can check that out in one of the earlier videos in my channel. So right now I'm going to do the same thing. I'm going to control the speed of the DC fan, but not by using any kind of a sensor, rather by using the hand gesture. For example, the separation between these two fingers is very small right now. And as I increase the separation between these two fingers, then the speed of the fan will gradually increase. And as I reduce the two fingers, then the speed of the motor will also reduce. And the intensity of this LED will change with the variation of the speed. And there will be a track bar or a speed bar in the laptop screen that will be showing us the percentage of the speed that the fan is currently operating at. So I believe I have been able to demonstrate the feature. I have been able to describe the feature of my project. So right now I'd like to talk about the components that I've used here. So as the microcontroller to generate the control signal, the analog values or the PWM signals, I've used the Arduino board. And for performing the computer vision based tasks, for estimating the distance between the two fingers or for tracking the movement of my hand, I have used the hand tracking module from the CVZone framework of Python. So these low-level microcontrollers like the Arduino or the ESP series microcontrollers or the STM series microcontrollers are not efficient enough in order to perform the computer vision based tasks. So we need Raspberry Pi or Jetson Nano. But for now I haven't deployed the project in Raspberry Pi or Jetson Nano. Rather, for the Python part, I have I have compiled the code on my computer, but later on in one of the later videos I'll show you on how you can deploy the same project on Raspberry Pi. So the separation between the two fingers is eventually converted to the width of the PWM or to the duty cycle of the pulse width modulated signal generated by the Arduino board. So there must be communication between the laptop and the Arduino board. To establish this communication, I have followed the serial communication protocol by using the serial module from the CVZone framework. So that's all about the microcontroller. As I've told you, I'll be running the Python script on my computer. And over here, as you can see, I have an LED that will be varying its intensity with the variation of speed. The greater the intensity, the greater the speed, the lower the intensity, the lower will be the speed. And over here, I have a pair of batteries. These are the 18650 lithium-ion batteries, 3.7 volt lithium-ion batteries. And over here, I have the DC motor. And to control the speed of the DC motor using the pulse width modulated signal generated by the Arduino board, I have designed a motor driver circuit using the NPN bipolar junction transistor BC547. So the PWM signal generated by the Arduino board has been fed to the base of the NPN BJT, and on basis of that, the speed of the fan will be controlled automatically. So it's completely based on gesture or based on hand gesture. We are not using any kind of sensors, and the speed will be varying with the separation of the distance between the tip of these two fingers. So it's completely AI based, more specifically computer vision based. It's kind of cognitive response in virtual reality, I should say. So I think I'm done with the components that I've used here. This pair of bulbs and the 2-channel 5-volt relay module will not come to any work for this project. So I'd like to dive into the demonstration right now. It will be a bit difficult, for me to show the demonstration in with one hand and then record a video with the other hand. So I've already plugged in my Arduino board, and I'd like to run the Python code, restarting the kernel. The serial device must be connected shortly. Let me see. Okay, I'm waiting. Yes, the serial device has been connected. Let me get it up. Okay, let me turn it off first, because it's already started tracking my hand. So first of all, I'm going to show you what happens in the screen, because simultaneously showing everything becomes a bit difficult. So as I get my finger, as you can see, a speed bar is visible in the screen. So as I increase the separation between my fingers, as you can see that the speed bar is also changing. If the speed is below 50%, then the bar is yellow, and if it is below 70%, if it is below 70%, then the bar is yellow, and if it is above 70%, then the bar is red. So as I increase the separation between the tip of my fingers, the speed increases, as you can see, and as I decrease the separation, the speed decreases. Let me adjust my laptop a bit. Yeah, now I believe I have been able to show. Okay, let me get it up. Yeah, you see the speed is increasing, the speed is decreasing. So it's really very precise, I should say. Maybe I'm not able to show that much clearly, you know. That's because of the fact that I've already told you that I'm doing everything with one hand. So that's what happens in the screen. And now I'm going to show you what happens practically. I mean how the speed of the fan varies. So I have to get the cell phone slightly upward. Yeah, so right now I'll be increasing the separation. You see the fan has turned on, the intensity of the LED is also going up. More the speed, you see 100% speed, and the separation is also maximum over there, as you can see 100%. The intensity of the LED is also maximum. Let me try to show it with my left hand. So you see the speed is now minimum. Trying to increase the speed. Reducing the speed. Increasing the speed. More. So right now I am at 50% speed. Right now I'm at 30% speed. Let me jump to 60%. Right now I'm at 60% speed. I believe you can see it in the screen. Around 60%, I should say. Now let's move to 90% speed or 80%. Right now I'm at 80% speed nearly. I believe you can see that. And I'm increasing the speed up to 100%, as you can see. So reducing, increasing, reducing, increasing. So that's how it works. I'm sorry, maybe I have not been able to illustrate the demonstration that much clearly, and that is because of the fact that I'm doing everything with one hand. So let me try to get the speed to 0. Yeah, the speed is set to 0, and the fan is well. When I'm getting my hand down, you know, the fan is turning on and the speed is increasing because my phone is on my left hand right now. So the speed is 0 right now, as you can see. So that's all about this project. Sorry for the messy demonstration. I hope you enjoyed it, how you can control the practical appliances using virtual reality. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.